Okay, both of these, maybe they were not easy yet, but after we review how to do them, hopefully these are a piece of cake. All right, so a 0.12 molar solution of a generic weak acid has a pH of 3.26. Determine the Ka. All right, you maybe will remember that Ka, the generalized statement for a weak acid, is that it's equal to x squared over initial. Oh boy. And my initial, okay, that's how it's going to be today? Yep, it is how it's going to be. It was fun. Thanks, Em, for letting me sit there for 30 seconds. All right, we'll come here, Diane, and take this seat. She didn't even answer. That's how good we're tight, like that. All right, the initial is equal to your given given concentration. Oh man, why did I write this word out? It sucks. Which is right here, right? And X is equal to the concentration of H plus. Okay, so this is given to me. So Ka equals something over 0.120, and X is equal to the concentration of H plus, which was not given to me, but it was sort of given to me, right? Because you can find H plus if you know the pH. Because H plus concentration is equal to the inverse log, which is 10, raised to a number, and it's raised to the negative pH. Okay? So now type that into your calculator, and what did you get, Griesbach? 5.5 times 10 to the negative fourth. And that is X. And now we have everything we need. So Ka equals 5.5 times 10 to the negative 4 squared divided by your initial, which it told you was 0.120. And you plug that in. Do you have that answer? Okay, that's supposed to be a line. 2.5 times 10 to the negative, that's a 6 or a 5? That's a 6. Can't even read my own writing. Okay. Did that make sense, Post? Yes. It's just been a day, right? All right. So if we have the pH and we have the initial, it's pretty simple. So now that we did number 1 together, take a minute or two and do number 2 if you haven't already done it. All right, so it's the same deal. We're going to use this to find the H plus concentration, which is the X for my Ka equals X squared over initial, right? So my Ka will be equal to 10 raised to the negative 2.39, because that's what will tell me this value. And I'm going to write it this way, squared, because that's what will be X, correct? And I divide that by 0.128. I sense someone walking out of the room right now. Oh, they were walking into, oh, they're going to blow their nose. I have magical senses. I have no idea what you mean by the shadow against that wall right there. Okay. And what did we end up with this? You're here, Diane. Anybody agree with that? All right, awesome job. Okay, we solid with that? This next one is from an old AP test, so it's a teeny bit harder. This thing, which I don't even know the name of, whatever that is, HC9H7O4, MW equals 180 grams per mole, that just means molecular weight, is prepared by dissolving 3.6 grams into a 1 liter solution. The pH is determined to be 2.6. What is Ka? All right, so what's the only wrinkle on this problem? All right, you have to find the molarity. So you just convert grams to moles. The liters is just 1, so that's the same, and solve it from there. So give that a shot if you would. Just wrote out all the parts. 10 raised to the negative 2.6 squared over 3.6 divided by 180. And hopefully that all calculates to be correct. So what do we get for that? Negative what? 4. Okay. Everyone okay with that? All right. So don't panic if they give you grams. If they give you grams, they'll either A, have to give you the formula and you add all the parts to find the molecular weight or molar mass, which is the same thing, or it might just give it to you. All right. So not too bad. Let's see what we got next. Okay. So here we go. Here we go. Gram sample of weak base is dissolved in enough distilled water to make 500 milliliters of solution. Calculate the molar concentration of that in the solution. So this is the same one, except for you have to find this molar mass. So just add the pieces. Write the equilibrium. This isn't even hard. Okay, so try this. There's no Ka or pH even in this problem. Okay, so let me just say that one more time. Since it's a weak base, the definition of a weak base is it does not dissociate very well. So we'll have more of the base than we would of its ion. Okay, so we would have more C2H5NH2 than C2H5NH3 because ethylamine is a weak base. Okay? Now there's math to that, but we don't need to do the math. It didn't even give us enough information to do math. All right? But if it says it's weak, then we know most of it does not dissociate. All right. Now, I didn't read this problem very well when I wrote D. So technically, I have a little misprint here. Anyone know what it is? Good. All right. This should be a B. And that really will matter. And if this part doesn't jive, well, I'll explain it a couple times. We just haven't done a base yet. But we can do it. If Kb equals 2.6 times 10 to the negative fifth, what is the pH of the original solution? Okay, so we're going to do the same math. 2.6 times 10 to the negative 5 equals my x squared over initial. The initial is this answer we got up here. So 0.66. So now, to solve math-wise, I take 0.66 over. Okay, then it's gone from there, and then I square root that product. Does anyone have that number? 0.004. Okay, 415. Okay. Oh, how do you make a 5 of 4? I haven't cheated that much in my life. I don't know how to pull that one off. All right. Now, that is x, correct? But this is a little bit different. This is equal to the OH minus concentration. So this is what you would do. Usually this equals H plus, right? Okay. So this is what you should do. Treat it just like normal. We're going to take the negative log of 0.00414, and usually that would tell me the pH. But in this problem, that's telling me the what? It's telling me the base, which is called POH. So plug this in for me. It's what? 2.38. Okay, now that is not my answer. My pH is equal to 14 minus 2.38. What's that? It does ask pH, so we have to have that answer. And then you'd put 2.38. But it will never really ask for that. Okay, so red flag, and I'm going to put a blue flag actually because all this problem is red. Okay, terrible looking flag, but I don't care. I should have read it more carefully. If it's a base, you have to do just that one more step. You do all the math the same, but you have to remember that when you do the math, you're finding POH. So the extra little nugget is you have to subtract that from 14. Is that okay? Thank you. What's that? Probably. Usually if I cut one and put it in here, it is from my test too. All right. Let's see what we got next. If you're like, man, I'm sick of practicing. Well, the whole plan today was just to do practice problems so you're comfortable. Do you have any questions on this before we move to the next one? I see kids writing stuff down, so I'll pause it. Okay, so I'll start that over. So the skills definitely need for these problems and the AP test. You have to be able to calculate molarity. You have to be able to write equilibrium expressions. You need to know what the definition of weak means. Weak means it stays as its substance and not in its ions. And then you have to be able to do math. Okay? Typically, the problems are Ka. Typically they are. But if they are Kb, which this I should have had a B there, then you solve for POH, which you subtract from pH. So lots of stuff on that one problem. All right. Did we do this problem? We did a different Hober problem yesterday.